You are given today's daily kth largest sum in a binary tree. You are given the root of a binary tree and a positive integer k. The level sum of the tree is the sum of values of the nodes that are on the same level. Return the kth largest level sum in the tree, not necessarily distinct. If there are fewer than k levels in the tree, return minus equals 1. Okay, so this is a little bit funky. Do we get any tips from the topics? Yeah, it is going to be a breadth first search. That's right. Okay, so we need to return the kth largest level sum, not just the largest level sum, meaning that really we just, my thoughts, I'll see if there's another way around, but since you need to return the kth largest level sum, you can't just hold on to a max because it might be like the fourth max or something. So I think the solution is going to be get all level sums sort them and get k index of the sorted level sums. Okay, so this part's easy. The trick is going to be getting all the level sums. How do we go about doing that? One second, I'm just going to turn on Do Not Disturb before I get text. Okay. Get all level sums, sort them, and get k index. Okay, so it's a binary tree. Okay, so I'm just gonna think out loud. I don't know why, but here's my initial thought: is basically to make is to recurse through with a parameter that tracks what level you're on. So recurse through with a parameter that tracks what level you're on. So when you say, okay, now get the values. Okay, wait, I think that's it. Recurse through with a parameter that tracks what level you're on. And then add to, we'll have an array that for which AI equals value at I. Do we want to just do like a dictionary? Because that way we can so what I'm thinking is we have an array. We don't want to deal with resizing it. We could maybe have it be a dictionary because then basically when you go through the levels you say, okay, add to the level 4 value, and so on. But really that's just like, if you're making a dictionary and the keys are just the values O through N, you might as well just have an array, in my opinion. And then one way we could save time is by doing one way we could save time by appending to the array. How about instead of appending to the array, at level I. Instead of appending to the array, we get max depth of binary tree, and that's the length of the array. So we can set the length right off the bat, and that won't take us long. We pass through all the elements, but should be in linear time. So it's just going through the tree twice. Is that faster? We can find out. The reason why I want to do that is because I don't like the idea of continuously appending to the array with every new level, because then we'd have to check like, okay, wait, is the array big enough? If it's not, then add to then extend it, and then extending is a problem because you're resizing the array, and that's not good because when you resize the array, the memory has to, it defined an address for that sequence of values, but when you resize it, then it's got to do a whole new thing. At least that's my understanding. So I think I want to do that. So first step is get max depth for levels array size, then recurse through tree with level parameter, adding to the answer levels array the value of the node, and then go through then just return sorted levels k. Sorry, reverse equals true, because we want the kth largest one, but sorted will inherently increase it. Awesome. Okay, let's do this. So it's like, so the sorted will make it be, well, the number of levels, which will be, it's sorting it would be n log n, and the number of levels is log n, where the n is the number of nodes. Okay, that's not bad. Okay, let's do this. So num levels, let's see. First we'll say get max depth. Okay, and that will just be, we just did this a second ago. Get max depth will be if not root return 0, and then otherwise return the maximum between 1 plus, the reason we do 1 plus is because now that we know that there is a root, we're counting the root itself, and then we're taking the max between the root left, get max depth on the root left, and 1 plus get max depth on root right. So we just did this. Actually, I did a video of this prior. If you're curious about, if you want to hear more about it, go watch that one. But yeah, so that will get us the maximum depth of the, so this will be a recursive function that'll get us the maximum depth, because we basically say, okay, if there is no root, then just return 0. Otherwise, well, don't count this. This one, it is not a root, so don't count it towards the depth. Otherwise, return whichever one's bigger between the recursive function on the left tree and then the recursive function on the right tree, and the entire time you're adding up those ones. Yeah, cool. So that'll get the max depth. Okay, so now we know that n equals get max depth on root. And then we can say level array equals 0 times n. So we have level array such that, let's just call it levels. Levels array such that levels I is the sum of the vowels at level, well, at the, well, on the ith level. Okay, so now we just need a recursive function that will recurse through and increment that parameter. So we'll say define level sum recurse. That's given a root and, or we'll just say a node. And we'll call it tn for tree node. We should also call that tn because it's not just the root. The root is the base. Okay. Level sum recurse is tn, and then we want to, actually, why don't we get cool and we could also do like the typing. And we're also given current level, or we could just say L is an integer. I was thinking we wanted to just preset the value, but and this is going to return nothing because it's just modifying levels in place. So we'll say okay, first, what if tree node is nothing? So if not tn, then just return, just stop the recursion. If otherwise, we say levels L plus equals tn.val, and then we just recurse by saying level sum recurse tn left with L plus 1. Actually, why don't we just say L plus equals 1, tn left and tn right. Sorry, no. Tn left L, tn right L. And then we just say level sum recurse. We initiate that recursion. We're going to do it with the root, and L is going to equal 0. And that'll recurse through. It's not going to return anything. And then we'll just return sorted levels reverse equals true. And we want k, because if it's the 0th largest, or is it the kth largest? Is k 1 through 0? Okay, yeah, so it'd be k minus 1, because we want to account for how the levels array is 0 indexed, but the k value is 1 indexed. Does that work? Yes, it does. Oh, no, it doesn't. What? Okay, so is that just one? What? List index out of range. Okay, well, let's see. We'll put p equals, a true in here, just as a little buffer to debug it. And then we'll see what levels equals after we okay, so 5, and then 8 plus 9 is 17, and then 2 plus 1 plus 3 plus 7 is 13, and then 4 plus 6 is 10. Cool, but what is it not like? We'll just submit and then take that test case. Maybe there will be one more bug, but that's weird that it's blocked out 45, but I was able to get 5. That's weird. N equals 3, K equals 4. Well, so we're looking for the oh, well, do we want to just say if what happens if K is larger than what? Am I crazy, or is K larger than N? The number of levels. If there are fewer, okay. So we can say if K is greater than N, return -1. I don't think that that'll work for all of them, though. Okay. Submit that. Yay! That's awesome. All right. Way to go. And we can get rid of this. What's that? That's not doing anything there, so we'll resubmit. Okay, pretty good runtime. Not the best memory. So we'll look at some solutions. But I'm pretty happy with that. So yeah, we go through and we get the maximum depth. That maximum depth is going to help us know whether or not the inputs are faulty, and how many levels there are. And then since we're setting up that levels thing with the number of levels that there are, we can just access that array for the certain level, for the ith level, and then recurse through. And then just start the recursion and then get the k-1 index of the reversed sorted list of sums of levels. Way to go! Okay, let's see. What doesn't work? Or what works? Yeah, so this is the same thing, except they didn't do the max first. They just did append. That maybe that's faster. I don't know. I also like mine because it stops it before you start the recursion. Okay, well, they do a queue. So I should hold on to that queue for level order traversal. DQ. Okay, so I'm going to remember that, but I'm pretty happy with mine. Thanks for watching.